there's one more replacement reaction I didn't get to. Okay, copy this down as another example. All right, I wanted to get to this one and then the exchange reactions, and we are done. It's Monday. The test is Thursday, and we will be done. We are done with all the material right now. We have a lab in between then. We have some review in between then, and some more worksheets to do to practice this. But this is basically it. Okay, sodium chloride plus fluorine yields. Now, this is also a replacement reaction, but it's not the kind you've been seeing. It's a little bit different. Okay, if you remember in the beginning, I had A plus BX yields, you don't have to copy this down, AX plus B. I also had, what else did I have?
AX plus Y.
AX plus Y yields AY plus X. So the difference was you can replace the positive ions or you can replace the negative ions, which I could do in this case. And that's what I'm going to do here. And you should be able to tell that because the guys that are going to replace each other should be similar. All right? When I had like sodium plus calcium nitrate, well, sodium and calcium are both metals, so they'll replace each other. Here, I've got sodium chloride plus fluorine. I'm not going to get what some people will put, fluorine chloride plus sodium. Fluorine's not going to replace sodium. He's not like sodium, is he? He's like chlorine. What do you think I'm going to get from sodium chloride plus fluorine yields?
Fluorine chloride plus
Oh my God. Did you all hear that? Because I can rewind that now because I've got it on tape. I just said it's not going to be fluorine chloride plus sodium. And Emily said it'll be fluorine.
Sodium chloride
Thank
plus chloride.
You're replacing the negative ions in these, okay? But thank you, Emily, for making my point. I do appreciate
I really had the right idea. I just said the wrong thing.
I'm sure you did.
I really did.
Mm-hmm.
And you spelled fluoride wrong.
No, I didn't.
That's how it's spelled.
I've been spelling that wrong in every test.
Yeah.
I think you have to spelling.
Keep going, Emily. Just keep. You know, when you're in a hole, stop digging. Okay? You're just digging. And you spell fluoride wrong anyway. And you're ugly.
You're talking about me.
Who's talking about you? Josh? You mean the one who lost whatever the supermodel to Tom Brady? I wouldn't worry about that. All right. Anyway. All right. Sodium chloride plus fluorine yields sodium fluoride plus chlorine. The rest of it's easy. You just write it out the way you normally would. But I guarantee you, go do it. Somebody will make a mistake. Do it. It's true. But Emily does learn from her mistakes. I'll give her that, and that's a good thing.
Like I don't have like bad grades. I like.
It's exactly right. That's why you should all make more mistakes. You'd make fewer on the test if you paid attention and tried more in the class and on the worksheets. That's the way to do it.
Fluoride.
Come on, do this one.
Oh, it's just Cl, isn't it?
Just do it. Figure it out.
Okay.
Yeah.
How about that?
I don't remember. I don't remember.
Did you remember? Yo, did you remember the diatomic elements when they're by themselves only? Don't put a diatomic element here or here because F and Cl are not by themselves. You just use whatever the charge are. Now, I'm not done yet. I still have to finish this guy. I've got 2 fluorines here, but only 1 there. So I'll just put a 2 there, and now it's all good, right? Cannot change subscripts. Put a 2 in front. That changes sodium. Need a 2 there. That gives me 2 chlorines. I've already got 2 chlorines. So he's done. Hey, just like the other ones, guys, these may or may not work. Does that guy work? Probably not, considering I just hinted at that. What do you think sodium bromide plus iodine is going to give me on my test? A big fat X. Why? Who wants to explain why?
I mean, I probably can explain my own question if you're being honest.
Well, why don't we read the 4? Remember, all these are listed in order. The 4th one under replacement reaction said what? Read it.
Replacement of halogens by other halogens, F greater than Cl greater than
Right.
Cl greater than
It tells you the order that can replace the order they can replace each other in.
I don't get that.
Okay.
I don't get
Oh
it.
boy.
Josh will explain it to you.
No, I won't.
Go ahead, Josh.
I don't want to.
Go ahead.
I don't want to.
Jared will explain it.
Because bromine is already more active than iodine.
That's one. Yeah, well, that's in this specific case, yes. But she's asking the generic question. All right, you have to look at the activity series again, just like you had to look at the activity series for the other ones. Hey, on that last worksheet, did you have some X's?
Yeah.
Same reason here. Take a look. You can look at one of two places at where it says F is greater than CL is greater. You can look at that, Emily, or you can look below on the right-hand side of the activity series. Who's the most active nonmetal?
Wait, so iodine,
Who's the most active nonmetal? Looking at the bottom part.
most active is fluorine.
Most active is fluorine, right? So fluorine can replace anybody. Iodine can't replace anybody. And the other guys go in order, right? And iodine is below bromine. Bromine's stronger than iodine. So iodine cannot replace them. Nothing will happen in this reaction. Just like nothing happened in the previous two other places we saw it. With water and with the first one, replacement reaction number 1. Okay, so you can see that again. All right, last one to do for you. I told you I only need a few minutes here. And I have a little demo for this one while you copy it down. This one is probably the easiest one to do, and it's probably also going to take you the most space. So you need to start this way over in the margin here, because you're going to have, for the double replacement reaction, sorry, this way over in the margin, I forgot. That's the actual notes on it. Double replacement, that's what they're called, exchange reactions. These are the last type. And their general formula looks like this. The reason they take up so much room is they have a compound plus a compound, use a compound plus a compound. So you got a lot of stuff to write out. I'll do a little demo for you on that in a second, but we'll copy this first one down. Actually, you know what? So you're paying attention, you're watching the demo, and then doing the thing separately. We'll do the whole thing right now. Turn that light on for me again.
I'm only going to do one example of these.
Yep, only one example of this guy.
Because I only have room for one.
And that's perfect. All right, just real quickly. Actually, I don't even need to put that in front of it. Yes, I'll just show it to you. It's not that take that long. I'm going to take some silver nitrate, which we've seen before. This is the stuff that turns your hands brown. Don't want to get it on your hands. And I'm going to add it to a test tube. And when I do that, you'll see that it's a clear solution. That's how I would describe this. A clear, colorless solution. You all agree? Now, I also have some cobalt chloride. So that's silver nitrate, is cobalt chloride. All of that will be written on the board in a second. How would you describe cobalt chloride if you were doing an observation on it?
It is brown. Right?
It's brown. Would you all agree it's brown? It's pink. All right, but so it's pink.
Yeah.
And whatever, pink or red, it's pink.
It looks like wine.
It looks like wine. I'm asking for, how do I describe this guy?
Clear.
Clear. Yeah, this is also clear. Both of these guys are clear. This guy's clear, and a lot of people make a mistake about this. Well, it's not clear, it's colored. It is colored, but it's also clear. I can see through it. It's pink, and it is clear also. But here's the point. When I put these two guys together, let's watch what happens.
An apple martini.
We get an appletini, yes. Put these two guys, what, you watching? Put these two guys together. Now, we should know what that is. What is that? When you take two clear solutions and you get a cloudy one, that eventually will settle to the bottom, an insoluble solid. Precipitate, I finally heard it. Precipitate. Remember that? We first saw precipitates back in the first chapter when I was doing physical versus chemical changes. Yeah, there it is, way back there. The word's over there, precipitate. I think, isn't it? Yeah, there it is. Yeah. All right, so let's do this reaction now. Now that you've seen it, let's do it. Put the that was the reaction. This is the equation. Okay, silver nitrate plus cobalt chloride yields. Now remember, start way over to the left, beyond the border on this one, because you won't have room. These are two compounds, and they're going to yield two compounds. So they're going to be a lot to write. Silver nitrate plus cobalt chloride is going to yield. Now, just like you'd expect from the generic formula, this is one of the, I told you it's one of the easiest ones to do. It's an exchange reaction. So they exchange places. What will I get from silver nitrate plus cobalt chloride?
Silver chloride plus cobalt.
Exactly. It doesn't matter what order I put that in. If you had cobalt nitrate first and then silver chloride, that would be fine too. Now, I am going to make a little qualification on this just for our viewing audience. As far as you're concerned, all of these work. As far as what we're going to learn later in the year, when we start talking about solutions and precipitates and aqueous and solids and liquids and all this other stuff, we're going to learn how to predict whether these reactions actually work or not. As far as you're concerned, I'm only going to give you ones that work. Okay, so you're going to just, that's why this makes it so easy right now. All you got to do is exchange places for these guys. Now, again, in the future, we'll learn how to predict the ones that actually do this and the other ones that don't. But for now, that's all you have to do. So anytime I give you any two guys, they're going to just switch places. Now, let's finish this up by writing the correct formulas, and we're all done. Silver nitrate would be Ag with a +1. I know that. He's a common ion sheet. He's in the middle of the periodic table. Can't tell what his charge is, but on the sheet it says +1. Nitrate is also on the sheet, -1. So his Ag803 is written correctly. Now cobalt, again, on the sheet, on the transition elements, the periodic table, can't use them. Got to look at the sheet. Cobalt has what charge? +2. Chloride is in the periodic table. Can figure him out with his common charge, -1, COCl2. Silver chloride, Ag +1, Cl -1. Cobalt nitrate, CO +2, NO3 -1. Now, what did I not do? And it's exactly what you won't do. Oh, I didn't balance it yet. Something else. I see this all the time. I wrote the charges, but I didn't use them. I get that all the time. How many of you, even just comparing your answers before? Did you see that? Anybody do that? I'll bet you did. You wrote the charges out, but you didn't use them. Okay? All right, now I'm ready to balance. Now, sometimes people have a problem with a guy like this, and I'll tell you why. They're looking at 2 times 3 is 6 O's and then 2 N's. No, you don't have to. When you have a polyatomic ion that did not change from one side to the other, he's pretty easy to balance. I can just look at it as a whole. How many nitrates do I have on this side? How many NO3s do I have? 2. How many nitrates do I have on this side? Just 1. So I'll put a 2 in front of that guy. Not in between, but in front of the whole compound. Now, 2 chlorides on that side, right? So can I change that chlorine to a 2 and make my life easy? No. I have to put it in front. And that actually does fix up my silvers as well. Okay? All right. You now have all of the types of reactions that I'm going to give